Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll find the domain and range of these two given functions. So let's start with the one on the left side, g at x. Now g at x is a quadratic function in vertex form. So as you may know, the graph of a quadratic function is a parabola. So the first thing we know about the parabola from this function is that the parabola opens down because the a value in this equation is negative. A value is negative 0.5. Now also we can find out the vertex of this parabola. So the vertex of this parabola is negative 3, comma 4. So we change the sign of the number in the parentheses. Now since this parabola opens down, that means the vertex represents the maximum point or the highest point on the parabola. So now we can write out the domain and range for this function. So as you may know, the domain is set of all possible x values for a relation or function. Now parabola is a shape that extends indefinitely on both sides of the graph. So the parabola will span the whole x-axis. So that means there is no restriction on the domain of this parabola. So therefore the domain in interval notation will be negative infinity to positive infinity. And for infinity, we always use the parentheses. Now in the other notation, the domain can also be written as xer. That means x can be any real number. Now we can write the range. Now as you may know, range is set of all possible y values for a relation or function. So for the range, we'll have to analyze the behavior of the graph along the y-axis. So as we just discussed, this parabola has a maximum point, and since this parabola opens down, that means this parabola spans all parts of y-axis below or equal to 4, because 4 is the y coordinate in the vertex. So that means the range in the interval notation can be written as negative infinity, comma 4, and 4 is part of the range because 4 is the y value in the vertex point, which is the maximum point in this case because the parabola opens down. So in the other notation, the range can be written as yer, and then y is less than or equal to 4. So this is the domain and range of this quadratic function. Now we can analyze the square root function. Square root only exists for a positive, a number, or 0. That means the expression under the square root has to be a positive number or equal to 0. So our first step is to set the expression to greater than or equal to 0, because square root doesn't exist for a negative number. So now we have to solve this inequality. So we have to isolate x on the left side. So for that we'll add 1 to both sides. So the ones on the left side cancel each other out and we get x is greater than or equal to, so 0 plus 1 is equal to 1. So this is the domain of this square root function. So we can write it in interval notation as 1 to infinity. So for 1 we are using the square brackets because 1 is part of the domain because it's greater than or equal to 1, and for infinity we always use the parentheses. So in the other notation, the domain can be written as xer, and x is greater than or equal to 1. And now the range, square root of any value will always be a 0 and all positive values. So the range will be 0 to infinity. So in the other notation, the range can be written as YER, and then Y is greater than or equal to 0. So this is the domain and range for this square root function. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.